Pop quiz. So this was a weekly pop quiz related to the topics which we have covered so far. The MCQs. If you have any doubt in question one, question number one, any doubt? Question two, question three, any doubt? If you have doubt, feel free to ask your doubts. You can just mention the question number and I'll discuss that question specific. Question number three, okay. In question three, two cables are attached to a bracket to exert a force, as shown you can see. What are the magnitudes of the horizontal and the vertical components of the resultant force? So how we can work out, first, if you see the 15 Newton force, so it will have two components. One is the horizontal, another one will be the vertical. The horizontal component in the component of the vector which is written with an angle is always the cosine. And the component of the vector which is opposite to the angle is sine. So what will be this component? What will be the component here, which is with an angle? So what we'll write, this will be 15 cosine 20 degrees. And the component opposite to the angle, what we'll write 15 sine 20 degrees. So 15 sine 20 degrees acting upward and the 15 cosine 20 degrees is acting towards the right hand side. Now, same way, we will resolve this vector, the 6 Newton vector, into the components. So this one is acting downward and this is towards the right hand side. So component of the vector which is written with an angle, like this is 6 and it's written with an angle. So this will be 6 cosine 40 degrees. And the opposite to the angle, it will be 6 sine 40 degrees, which is towards the right hand side and this is downward. Now, if we need the horizontal resultant horizontal component, one of the component is acting upward, another one is acting downward. So what we will do, we'll subtract because one of the vector is acting up, the other vector is acting down. So if you need the resultant, you will subtract. So it will be 15 sine 20 degrees minus 6 cosine 40. That is a vector which is, why we subtract them? As you can see, one is acting upward, another one is acting downward. What about the horizontal components? Because both the horizontal components are acting towards the right hand side. So if we need the resultant, we will add them. So this will be 15 cosine 20, the horizontal component, plus 6 sine 40 degrees. Is it clear, this one? So whenever the vectors are acting in the same direction, we will add to get the resultant. If they're acting in opposite direction, we'll subtract to get the resultant, to find the resultant. Question 4 and 5, any doubt? Question 4 and question 5. Any doubts? Question 4 and question 5, okay? Look, in question 4, the curved line PQR is the velocity time graph for a car starts from rest. What is the average acceleration of the car for the first 5 seconds? Look, if we need an acceleration, how to work out the acceleration? To work out the acceleration, we take a gradient. That is the first thing. So option A and B are totally wrong. Why option A and B are totally wrong? Because it's area, velocity time graph. If we use area, we find the displacement. Now, the two options are there. If you read the question, it's written average. Because of as you can see, the slope is continuously changing. In the beginning, it has a lower gradient as compared to as it moves, it gets steeper. So the gradient is continuously changing or the slope is continuously changing. So if we need an average speed, if we need an average acceleration, so what we need the gradient of this part only from P to Q. If we take gradient of this section of the graph, what we will get? We will get an average acceleration. But if we want an instantaneous acceleration at a specific point, then what we have to do? We have to take a gradient of that, like we have to draw a tangent and find the gradient of the tangent. So if I need the acceleration, the specific acceleration at point Q, what I have to do? I have to draw a tangent at point Q, and then I have to work out the gradient of this tangent, and that will give me the acceleration at that specific point. But if I need the average acceleration, so acceleration is continuously changing. If we need an average acceleration, we draw a line from starting point to the final point, and we take the gradient of that part, and we call that as average acceleration. That's why C is the right answer for this. Is it clear? Question 4. Why B cannot be a right answer? Because if you use the area will give us the distance traveled by an object. The area of the graph will always give us the distance traveled by an object. That's why A and B cannot be an answer. So two options are there. If we have a velocity time graph and it is a straight line, if we have a velocity and time graph and it is a straight line, so straight line means the acceleration is constant. So whenever constant acceleration is there, if I work out the average acceleration or I work out the instantaneous acceleration means acceleration at a specific point. If I work out acceleration at this point 1 or point 2, I'll get the same answer. So whenever there's a straight line, the average acceleration and instantaneous accelerations are the same thing. But what if we have a curve? If we have a velocity time graph and it's a curve, it means the acceleration is not constant, it is continuously changing. Say that if the acceleration was decreasing and we were having a graph like this, and I mention a point, say this is point P and this one is point Q. And I need acceleration, the average acceleration. So if I need an average acceleration for this part, what I will do, I will draw a straight line from this part, like from starting till the end, and I'll find the gradient of that straight region. That will give us the average acceleration. But if I need an instantaneous acceleration at a specific point, what we will do, we will always draw a tangent. Like if I need an acceleration at specifically at this point, so I will draw a tangent at this point. Is it clear? Any doubt in this? Okay. Question number 5. can you show the first page? I need to take the screenshot. The first page, I have already recorded, so I will share the recording at the end. You can check the recording because I erased that. This is not a permanent. I'm just using erasable, annotation. That's why it will not come back again. In question 5, a ball is thrown horizontally with a speed of 10 meters per second. So there's a ball which we throw at a speed of 10 meters per second above the ground. It hits after 3 seconds. For example, this is representing a ground and it takes 3 seconds to hit the ground. What will be the trajectory or the path which this ball will follow? It will be a projectile. And in a projectile motion, it will have the two components, horizontal and vertical. This will be the trajectory or the path it will follow. So we need the speed at which the ball just hit. So we need this part, the speed at which it hits. This speed at which it hits the ground will have the two components. It will have the horizontal component and it will have the vertical component. The horizontal component, as we assume in a projectile motion, as there is no air resistance, so we assume that the air resistance is not there, so horizontal component remains same. So if the beginning it was 10, after like once at the moment it hits the ground, the horizontal component will be 10. But what about the vertical component? The vertical component will have an acceleration. In the beginning, the vertical component is 0 because when a projectile is launched horizontally, there is no vertical component. And the vertical component will have an acceleration which is due to gravity 9.8. So first what we do, we have the horizontal component. First we'll work out the final vertical component. By using the equation of the motion, V equals U plus AT. The initial vertical is 0. The acceleration is due to gravity, which is 9.8, and it took 3 seconds to hit the ground. So 9.8 multiplied by 3, what's the answer? 9 multiplied by 3, 27, and 0.8 multiplied by 3, it will be 2.4. So it will be 29.4 meters per second. So 29.4 meters per second is a vertical component. But the question is calculate the speed. So we want this speed at which it hits because this speed will have the two components, the horizontal and the vertical. So how we can work out the final speed? Like we want to work out at what speed it hits. It will have the horizontal component as 10 meters per second and the vertical component as 29.4 meters per second. So we can use a Pythagoras theorem as the hypotenuse is the resultant for us. So the speed is equals to under root the horizontal component square, which is 10 square, and the vertical component square, which is 29.4 square. So 10 square plus 29.4 square in a root, that will give us the speed at which it hits the ground, which will be about 31 meters per second. Is it clear? Does the horizontal velocity turn 0 towards the end when it hits? The horizontal velocity, because we just need the speed at which it hits. So speed at which it hits, it will make a certain angle in a projectile motion as there is a horizontal and the vertical component. So first, when I work out the final velocity, this final velocity is the vertical velocity, the vertical component of the velocity. The horizontal, it is already having the horizontal component, which is 10. So horizontal component does not change and the vertical component accelerate due to the gravity. So the combination of the horizontal and the vertical components will give us the final speed at which this object will hit the ground. So this object does not hit the ground vertically. No, this object will hit the ground and it will make certain angle with the ground. And it will have the two components, horizontal and the vertical. Is it clear? Question 6 and question 7. Any doubt? Question 6 or question 7? Question 7. In question 7, you need the force. The formula of the force which you can use, F equals ma. And what about A? Acceleration is a change in velocity divided by time. Now, in the question, they mentioned when the jet of a water hits the wall horizontally with the velocity v, so means this is the initial velocity which is v, the water does not rebound from the wall. So if the water does not rebound from the wall, what is the final velocity of the water we'll consider? The final velocity we'll consider as 0 because it does not rebound. It just stops. So we have the formula F equals ma, or we can also write force is equals to change in velocity divided by time. So m, what about the final speed? The final speed is 0. What about the initial speed? The initial speed is negative v. Why negative? Because it's in terms of the direction and divided by time t. So F is equals to negative minus mv over t. Is it clear till this point? How is possible water won't rebound? In the question it is given here. When the jet of a water hits the wall, the water does not rebound from the wall. So means the impact of this water is all taken by the wall. That's why the water does not rebound. So the final speed of the water is 0. The initial speed is v. So we have the formula now that F is equals to, because we just need the magnitude of the force, so I can consider F is equals to mv over t. What about the mass? Because in terms of the density, density is mass over volume. So what about the mass? The mass will be density times volume. This volume, this V is a volume, so I will just make it curve. So F is equals, in place of the mass, I can substitute the density into volume into V, the velocity divided by time. What about the volume? We have the cross-sectional area at which it hits. And if example, this is a distance or the length is there, distance or D or a length. So I can substitute that the volume is what? Volume is area multiplied by distance or area multiplied by length. So in place of volume, I can write area multiplied by length. So F is equals to rho. This I can write area multiplied by length into V, the speed divided by time. What is length divided by time? The distance divided by time, that is also speed. So I can say F is equals to rho A. This is V because length over time, and this is also V. So when V is multiplied with V, that will become density, area, and V square. So we got density, area, and V square. We got the option D. This is one way of solving the question. There is also another way. The second way is you work out the base unit for each of these expressions. If the base unit matches with the force, because what is the base unit of the force? The base unit of the force is kilogram, meter, second raised to power minus 2. So what I will do, I will work out the base unit for each expression. If the base unit of the expression matches with kilogram meter per second square, that will be the right option. So either you use the base unit method to work out which relation is correct, or you can derive a formula to work out that which one will be the correct equation. Is it clear? Question 7. Any doubt in this? Question 8, question 9. Any doubt? Question 8, 9. Question 10, question 8. Okay. In question 8, which diagram shows the direction of the forces or forces acting on a projectile at X? If you read the question, they mention it is moving through the air. So means they did not neglect the air resistance. So the projectile will have the two components, horizontal and the vertical. So means it is moving horizontally. So if it is moving horizontally, what will be the force which opposes the motion? The air resistance or the drag will be the force which opposes the motion. So one of the force which try to oppose the motion, that is at position X, it will be on the left hand side. Another thing, because this projectile does not leave the earth, so it is influence of the gravity. So there should be a gravitational force or the weight of a projectile which is acting downward. So what are the two forces which are acting on this projectile? One is the drag or the air resistance, and the second one is the weight of this projectile. Question 10, 11, 12. Any doubt? 10, 11 or 12? Question 13, 14. Any doubt? Can you, one of the question, why it is not A for question 8? Why, one of the student asked why there is no upthrust. Remember, upthrust of the air is negligible. If the upthrust was a considerable force for an object, then what should happen to this projectile? Like these arrows are shown here. So it means there's this projectile, this is the whole motion of the projectile. So weight is always acting downward. One of the force will be the weight. The air resistance is acting opposing the motion. So it's moving towards the right, so air resistance is opposite. Why not upthrust? Upthrust of the air is always neglected. Negligible upthrust, which does not balance with any of the force. Upthrust is considerable in the fluid, the liquids. So why A cannot be an answer? Because there is no engine or the thrust to move this. And whenever object is moving towards right, if the motion is towards the right hand side, the friction is always try to oppose the motion. So friction is towards the left hand side. Drag is not negligible. Why drag is not negligible? Because they specify here that it is traveling through the air. So if it's traveling through the air, drag cannot be neglected. Then question 14. In question 14, the graph shows the vertical velocity of a parachutist during the first 20 seconds of her jump. Approximately how far does she fall before opening a parachute? So we have to first mark a point where she opens a parachute. Where she opens a parachute? At which point she opens the parachute? You can annotate on the screen to mark the point. At which point she opens the parachute on this graph. What is the point? Yeah, that's right. So this is a point. That's right. So this is a point where she opens the parachute. So what we have to do, we have to just, that's right. We have to just work out the distance till this point. So whenever it's a non-linear graph, if it's a non-linear graph, what we do? We divide our graph into equal horizontal and vertical portions. So if I'm drawing vertical lines after 3 boxes, so I will draw. So I drew the vertical line after 3 boxes. Then the horizontal lines. Now what we do? Area of each box, like we can count the number of the boxes. So this will be 1, 2, 3, 4, 5, 6, 7, 8, These two together I can take as 9. Like even this one also 9 and this one I can take as 10. So approximately I got 10 boxes. What is the area of each box? So starting from 10 and ending at 13. So this is 3 and this one is 20. So length multiplied by width. So approximate area of each box is equals to 60. And how many boxes we have? 10. So 60 multiplied by 10, it is about 600. So 600, which is the closest answer to 600 because approximation is used. So we have 570 meters. So B will be the right answer. Is it clear? Question 13. Okay, sure. In question 13, we have a velocity time graph. In question 13, we have a velocity time graph because it is a straight line. So it means it has the slope of a straight line is a constant. So it means acceleration is constant. Means acceleration is not changing. If we have a velocity acceleration graph, means the graph is there between a velocity and acceleration in which velocity is increasing, as you can see, but the acceleration is not changing. So which is the right graph? It means D is the right graph because the acceleration is not changing. The value of the acceleration remains same, even though the value of the velocity is continuously changing. So D is the right answer. Question 15 and 16, any doubt? Why not C? Because in C, what it shows velocity is not changing and acceleration is increasing. But we want a constant acceleration as a gradient is constant. The slope is constant for velocity time graph, which shows acceleration is constant. But if you select C as an answer, it means the acceleration value is continuously increasing. Question 16. In question 16, a mass of 0.2 kg is suspended from a lower end of a light spring. Because the mass of a spring is neglected here, that's why it's written light spring. A second mass of a 0.1 kg is suspended from a first mass by a thread, and the arrangement is allowed to come in static equilibrium, means like it is stationary. The question is, what is the immediately after the thread is cut, what is the upward acceleration of this mass? First, when it is in equilibrium, if you work out the force, because there is no resultant force acting, so what will be the force on the spring initially when it is at rest? The total mass of a 0.1 and 0.2. So the total mass is actually 0.3 kg, which is, so what will be the weight of this all? What will be the weight of this all? So weight is mass multiplied by gravity. So mass is 0.3 and the gravity is 9.8. So 0.3 multiplied by 9.8. What's the answer for this? 0.3 into 9.8. Because first, when it is in equilibrium, the total downward force should be equal to total upward force. So we are finding the total downward force. So 2.94 newtons. So when it is in equilibrium, the total downward force is 2.94 Newton. So how much is the force of the spring? The force of the spring should also be 2.94 Newton. The force of the spring is also 2.94 Newton. That is first thing. Now, what we did, we cut this thread. So when we cut the thread, the moment we cut the thread, now what is the downward force? It was 2.94 initially, but now it's not 2.94. The total downward force is how much? It will be 0.2 is the mass and the gravity is 9.8. What's the answer for 0.2 multiplied by 9.8? So it will be 1.96 newtons. So now the downward force is 1.96 Newton and upward force from the spring, because spring is having a restoring force, it will try to pull this object. So as a result, what will the resultant force on this? Because the two forces are acting in opposite direction. So 2.94 is acting upward and 1.96 is acting downward. So the resultant force which the spring will experience, that is 0.981 Newton is a resultant force. And we have the formula that the resultant force is equals to MA. So resultant force is 0.98 Newton. The mass, what is the mass here? Mass is equals to 0.2. And then this is the A, because the mass which is attached is 0.2. We need an expression, so 0.98 divided by 0.2. What is the answer for this? So it will be 4.9 meters per second square, or it will match with A. Is it clear, this one? Question 17, 18, any doubt on 17 or 18? Question 19, any doubt? In question 19, the forces are acting, as you can see. We select a diagram which represent a free body force diagram. A boy is moving this heavy box. So this is the direction of the motion. So the forces which are acting, whenever we apply a force by using a string or a wire, that force is called a tension. The surface, whenever objects are in contact with the surface, there's a normal contact force, or R will be there. You can say N or you can also say R. It's the same thing. Some books N, some book R, but it's perpendicular. Then the weight is also acting downward. And what else will be the frictional force of the ground? Because they did not mention that this ground is a smooth, so frictional force is there. So friction always try to oppose the motion. So if the motion is toward the right, the direction of the friction is towards the left-hand side. So we have to select the diagram which represent the free body force diagram for the box. So the direction, as you can see here, R is, what is a mistake in B and D, that the direction of the R is not correct, because R should always be perpendicular. So if this was an inclined surface, R should be perpendicular. So either A can be an answer or C can be an answer. Now, why we select A, why not C? If you check, this is a tension. Here is an R, W, and the friction. So why we did not draw the same length for the friction and the tension? The main reason is that because there is a component. So this one is a tension. Here is an R, here is a W and a friction. So what will happen if we resolve the normal contact force into the component? So the normal contact force will have two components. Or if you resolve the weight into the any one of them, you can resolve into the component. So if you resolve the weight into the component, The weight will have the two components. One of the component of the weight, which is with an angle, that will be W cosine theta. And this W cosine theta will balance the R. And another component will be there, W sine theta, which is forcing this object to slide. So W sine theta and friction are the two forces which are balancing with the tension, T. That's why we did not draw the same length for the tension and the friction. You can see the friction arrow is slightly shorter as compared to that of tension. So what is the reason for that? Because there is another component which is acting backward or opposing the motion, that is the W sine theta. So the W sine theta plus the friction will be equals to tension. But what is a mistake in this diagram? That the length of the tension and the friction is drawn same. So it means, what does it mean? It means that there will be a component of the weight which is W sine theta, and that W sine theta is also acting along the slope to slide this object down. So as a result, the friction and the W sine theta, their sum will be more than the tension. So what should happen to this box? This box should slide down, but the box is not sliding down. The box is moving up on the inclined plane. Is it clear? This one? Why the tension and the frictions are not equal? Because what will happen, the weight will have the component, one of the component is with an angle W cosine theta, and opposite to the angle is W sine theta. So W sine theta and the friction are balancing the tension. So why we did not draw the same length for the tension and the friction? If the tension and the friction have the same length, and there's another component which is W sine theta, so what should happen to this box? This box should have a more greater force to move downward than upward. So this box should slide down. And the vertical, this W cosine theta balances with a normal contact force. Is it clear? Question 20, any doubt? So this was a pop quiz, the MCQs pop quiz. I'll share another link and we'll discuss the structure pop quiz, and then we'll start